the double linked list. The double linked list. The double linked list is a variation of linked list in which navigation is possible in both ways, either forward and backward easily, as compared to a single linked list. So we can see here a diagram. It's more or less showing a double linked list. So let's first define some terms. A link. Each link of a linked list can store data called an element, and sometimes we call a link a node also. Next, each link of a linked list contains a link to the next link, and it's called next. Prev. Each link of a linked list contains a link to the previous link, and it's called prev. So the linked list, that's a whole list. A linked list contains the connection link to the first link called first or head, and to the last link called last or sometimes called tail. So this is the doubly linked list representation. So as per above illustration, the following are the important points to be considered. A doubly linked list contains a link element called first and last, or head and tail. So here is the first one, or the head, and this one is the tail. Each link carries a data field or fields and two link fields called next and previous. So this is a link or a node, and each link can contain data fields. So A here, B and C are data fields, so it can be just a single data or multiple data. And it also contains two links, the previous and the next link. Each link is linked with its next link using its next link. So each link, this is the link, is linked to the next link using its next link. Again, I repeat, each link, so this is a link, this is a link, this is a link, is linked to the next link using the its next link. So using this, we have here, this one is pointing to the next element. So each link is linked with its previous link using its previous or prev link. So let's take a look at this link. So each link is linked with the previous link using the prev or previous link. So using this one is pointing to the previous link. So the next is pointing to the next link, and the prev is pointing to the previous link. The last link carries a link. So the last link carries a link as null. So next is null to mark the end of the list. Actually, there are two ends here. The head is also an end if we do the reverse. So the previous for this one is also pointing to null, and next here is also pointing to null to denote the end of the list. So these are the basic operations. So we have insertion, so adds an element at the beginning of the list, so that's the same as insert first. Deletion, deletes an element at the beginning of the list, or delete first. Insert last, adds an element at the end of the list. Then delete last, deletes an element from the end of the list. Insert after, adds an element after an item of the list. Then delete, deletes an element from the list using the key. Display forward, displays the complete list in a forward manner, so from head to tail. And display backward, displays the complete list in a backward manner, so this will be from the tail up to the head. So let's now discuss the insert first operation. So this will be our source code for the insert first operation. What we'll be concentrating will be on this. So we'll be illustrating the, but on this first part, what we just did here is we actually created a blank link. So by allocating a memory for that link, and then typecasting that memory into a node, so equal to our node, our link. And then here we assign the data from our parameter, previous to null. Then if it is empty, last is equal to link, but we'll not be discussing that anymore. We have discussed that in our previous slide. So we'll be concentrating now on this part. So, but basically what we have done here is create a blank link. So this is our original list, and in our code, we actually have created a new blank link, and we have assigned the data to our link, and previous is null. So again, let's go back to this code. So in our code, it says here that head previous is equal to link. So this is our head. This part is the head. Again, head is pointing to this, and that means that this is also our head node. So head prev is this part is equal to link. That's why this will be equal to link or pointing to the link. Again, the link is the new link. So this one will be pointing to this. So that is what is done in this part of this code. And then on the next code, link next is equal to head. So this is the link, and this is next. So link next is equal to head. So head is still pointing to this node or this link. So again, next here will be pointing to where the head is pointing, which is this one. So that's what the arrow indicates here, the red arrow. And then on the next line, head is equal to link. So previously head is pointing here. This time head now will be pointing to the link. So that moves the head to this part. And if we're going to look at this one, we have now a new list. So if we're going to traverse the list, head is pointing to this, which is our new link. And then this link will be, if you use the next link, it will point to this link, and this link will point to this link, and then this link will point to null, which means the end of the link. So we have now inserted the link inside our linked list. Okay, so let's now proceed with the delete operation. So again, this will be our code, and so we'll be concentrating on this one. So head next prev is equal to null. So again, this is the head. So head next prev is equal to null. So we are targeting this portion. So now we have assigned null to this. So that means that this is no longer pointing to this node or this link. So there are no more nodes pointing to the head or previous. And then head is equal to head next. So head next. So head next, this is head next, is equal to head. So this one. Okay, head next. This is actually head next. This is head next. Will be the new value of head. So that means head will be now moving to this. So basically that's it. You notice now that there's no longer any node pointing to this link. So we have deleted the first element. Then we have insert last. So the same, we'll be skipping this part. This will just create the node and etc. So let's concentrate on this last part. So again, this is the first part. We created the blank link, etc. So this is our original list. So here now, last next. So last next is equal to the new link we have created. So that's what we're going to do in this code. So last next is equal to link. So this is the link, the new link. And then link previous. So this is the link previous will be equal to last. So this is the link previous is now pointing to last. So this is the last node. And then last is equal to link. So previously last is pointing to this node. Now last is pointing to this link because this is our last node or new last node. So that ends the operation. The next operations will be discussed in the next slides or next video. Thank you.